G'day people, welcome to the next video. This is spatial patterns. Now this entire unit, this entire topic is about recognizing patterns and finding them where they're hard to find, just like we did with the number patterns last time. And once you've found that pattern, using that pattern to predict what's next. That's the whole skill that we're developing here, and we're developing it with almost any type of pattern at all. And this time we're on to spatial patterns. Now what's a spatial pattern? That's a spatial pattern. Right? It's a pattern that's drawn rather than just a bunch of numbers. Right? 1 square, 2 squares, 3 squares. I'm sure you can see the pattern in that. Now, this is one of those areas in math. This particular section is one of those areas in math that is easy, but looks difficult because of how the questions are worded. And again, doing maths is easy. Understanding the question is often the hard part. And this is a bit of a doozy of an area for having to understand the question. So I'm going to take you through the typical questions that get asked about this, and I'm going to sort of put them in plain English for you so you understand what they mean. Because one of the big sticking points in mastering this particular section of maths is understanding what they're actually asking you to do. So first thing they ask you to do, first typical question is this: draw the next two shapes. All right, okay, so there's the first three shapes. Clearly there's 1 square, there's 2 squares, there's 3 squares. The next two shapes would be 4 squares and 5 squares. Okay, so that's easy enough. Right? So draw the next two shapes. That's the easy one. It's easily understood and it's easily done. What comes up a little next is a little bit more complex. Okay. Write the spatial pattern as a number pattern. And sometimes they add this green bit as well, relating the number of sticks required to make each shape. Now what the hell does that mean? What it means is basically count the parts that are necessary to make that shape and list it as a bunch of numbers. First shape, that takes 4 sticks, if we're going to call them sticks. Right? So that's 4. The next one, now by the way, this is a classic rookie error. A lot of people go, oh, that took 4 sticks. That'll take 8, that'll take 12, right? 1 square, 2 squares, 3 squares, 4, 8, 12. Makes complete sense, but that's actually wrong. Because this one takes 1, 2, 3, 4, 5, 6, 7. And the next one, if you do the same thing, takes 10. So why isn't it 4, 8, 12 like you'd probably expect? The reason for that is that you don't have to do the entire rest of the square, the entire next square, because one of the sides is already there. Right? That was the first square, and this side here is also the first side of the next square. So this one there, this one here, this stick is doing 2 jobs. It belongs to 2 squares, right? So it ends up being 7, not 8. You need 1 stick less. And for this one, you need 2 sticks less because this one is doing 2 jobs and this one is doing 2 jobs as well. So instead of being 12, it's 2 sticks less than 12, which is 10, right? But that's what they mean. Turn it into a number pattern. Okay. And if they draw 5 shapes and say turn that into a number pattern, you just draw 5 numbers. So that's easy enough. But the way they write it, with spatial pattern, turn it into a number pattern, relating the number of sticks required, it sounds a lot worse than it is. That's all they're meaning. Okay. Next question. Oh my God, it's a paragraph. Describe the pattern by stating how many sticks are required to make the first term and how many sticks are required to make the next term in the pattern. What the heck? Okay, here's our little sequence here. All you have to do is say how many sticks were used, how many sticks were used to make the first pattern, 4, and how many sticks are required to make each next pattern, right? And this is where going back to the number patterns helps. Now that you've got a number pattern, you can look for a common difference. 4 plus 3 is 7. 7 plus 3 is 10. So the next one would probably be 13, right? So to answer this question, there are 2 parts. It says state how many sticks are required to make the first term. Okay, so let's do that. I'm going to answer this one. In this case, 4 sticks required for the first term. Right, that's the first part of the answer. and how many sticks are required to make the next term in the pattern. So no matter where you are in the pattern, if you wanted to make the next one, how would you do it? Well, let me just show you with a blank piece of paper here. Right, got a blank piece of paper. I'll leave this up here. So having made the first shape, how many extra sticks do I need to turn that into the second shape? Right. In fact, let's color coordinate it. 1, 2, 3. That is now the next shape. And how many would I need to make the next shape? Another 1, 2, 3. That's the third shape. Okay. So it turns out that once I've done this 4, once I've made these 4 sticks required for the first term, right, to make each next term, I only need to add another 3. Every single time I'm going to go 1, 2, 3, 1, 2, 3, and I'm going to add another square. Okay. So this question is so long because it's asking you to do 2 things. It's asking you to say, well, how many sticks do you need to start it? And then how many extra sticks do you need to continue it? So the second part of your answer is 3 sticks, I'm getting a bit squishy here, required for each next term. And a term, by the way, is just one instance of it. That's a term, that's the next term, that's the next term, right? That's all that means. Okay, so that very long, strange, intimidating looking question is not all that bad. It's just got a really long way to say itself. Next question. You often get to this. Complete the table. Just going to move the camera a little bit here. There you go. Now the only reason there's a second table there is because I'm going to show you this again for another example in a minute. But that's the question. So it says complete the table, and it's got number of shapes, number of sticks required. Okay, so here's our now very messy picture. So that's one shape. This has got 2 shapes. This has got 3 shapes. So that's what these numbers are. Right? The shape that we're talking about is squares here. It could be triangles, could be hexagons, could be anything. Right? But in this case, it happens to be squares, and this is what we're saying. Right? So how many sticks did it take to build the first one? It took 4. I'm just going to get a slightly darker pen here. Right. It took 4 sticks to build the first one. It took a total of 7 for the next one. So we're basically just doing this. Right. 10. It would take another 3 because we've realized that we had to add 3 to make another shape. Another 3, another 3. All right. So that is really a very short way of showing all of this. Right. So this is basically putting it into words, and this is putting it into a table, making it way shorter. Right. One good thing about maths is they always look for the short way of doing things. This is the short way of doing that. They're essentially the same question. All right. Sorry. Last question they're likely to ask you. This is where the real brains comes in. Having done all of that, it says predict how many sticks it would take to make a pattern with 10 shapes. So if I wanted to draw one of those things with 10 squares. So let me get these back because this is pretty clean. This is the 4 and the 5 square shape. Right? So this will have 13 sticks, and this one will have 16 sticks. 5 squares, 16 sticks. So I bet I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It works, right? So this is correct. So having seen that, predict how many sticks it would take to make one of these that was 10 squares long. Right? So by the time you've filled out that table and by the time you've drawn 5 of these shapes, etc., you should be seeing the pattern well enough to be able to make predictions without actually drawing a shape that's got 10 squares, right? Without actually covering a whole piece of paper with squares and sticks and so forth. You should be able to predict it. You should be able to predict how many sticks you would be required to make something with 100 shapes, right? So let's tackle this one. We know that the first one takes 4. And that after that, every next one takes another 3. So you have to click on 3 more, click on 3 more. Right? So for this one here, a way to write this is that this is made of 4 for the first one, plus 4 lots of 3, because each of these last 4 took 3 sticks. Right? And this one here would be 4 for the first one, plus 1, 2, 3 lots of 3. So if we had one with 10 squares, what would that look like? Right? Surely, for 10 squares, the pattern would be 4 for the first one, plus, and how many squares have we got left? We've got to make another 9 squares, so we'd have to go 9 lots of 3. That is the prediction. That's how we're going to work this out. Let's have a look. So what does that come to? 3 times 9 is 27. 27 plus 4 is 31. So that equals 31 sticks. So without drawing it, and this is the good thing about patterns and predictions, right? Without doing it, we already know that we would need 31 sticks to make this, right? To make one of these shapes that had 10 squares instead of 5, right? And this is used all the time, this sort of patterning and using patterns to predict things, right? People, before somebody makes a footpath along a 10-kilometer long road, they don't count the square meters going 1, 2, 3, 4. They don't walk it counting how many meters it's going to be. They don't count how many tiles they're going to need to do the entire bathroom or to do an entire paveway. Right? The people who put the bricked paveway in your school didn't count the spots where bricks would go before they ordered the bricks. They did a little bit of it and figured out how many bricks would take to make it maybe a square meter, and then extended that pattern out. Right? This is a very important skill. This is a fantastic time-saving skill to develop. Right? Recognizing a pattern for something small and using it to predict the needs of something really big. This is done worldwide all the time, and it's one of man's great skills. And you are halfway through developing it right now, my friends. Right, I'm going to show you this very quickly with one more shape. Ta-da! There's another shape. Okay, this isn't squares. This is a little bit more complicated, but don't get scared of complications because you have the system. All right, let's have a look at this. I'm assuming that you know exactly how to draw the next two. We're not going to worry about drawing the next two, okay? So these are made of sticks. It's just another pattern made of these sticks. And we're obviously adding one more little sort of rocket ship to each pattern. Okay, so the first of these other questions. Write the spatial pattern as a number pattern relating the number of sticks required to make each shape. How many sticks for that? How many sticks for that? How many sticks for that? Okay, so let's do it. First one takes 1, 2, 3, 4, 5, 6, 7. Okay, 7. Second one. It's not necessarily going to go 7, 14, 21. So you actually have to count them before you realize what the pattern is. You're probably going to get it wrong if you just go 7, 14, 21. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Now 7 plus 5 is 12. So I reckon the next one is going to be 5 more, which is 17. But I'm going to check. 1, 2, 3, 4, 5, 6. Sorry. Trying to fit it all on the screen. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I was right. Okay. That's the answer to that question. Done. Describe the pattern by stating how many sticks are required to make the first term and how many sticks are required to make the next term in the pattern. Okay. Well, there were 7 required for the first. Okay, because the first number over here was 7. And you need an extra 5 for each subsequent term, right? We added 5 and we added 5. So that we needed 5 more sticks to turn this into this. We needed another 5 more sticks to turn that into that, right? So the rest of this is 5 required for each next term. No matter which one you're up to, if you want to make the next one, you're going to need another 5 sticks. Okay. Now let's do that in a table. I can straighten it up for you. Okay, number of shapes. Number of shapes with an S. There you go. 1, 2, 3, 4, 5. We've already got the first three. We already know that that was 7, 12, and 17, right? Just there. Already done half of this question. And now that we know that we're just adding 5, you don't have to draw it again, right? If you have drawn it, you can always count it, but we know the pattern now, right? Add another 5. 17 plus 5 is 22. 22 plus 5 is 27. So without drawing it, right, we've gotten to the stage where we can predict. Okay, which is lucky because the next question says do just that. Predict how many sticks would be required for a pattern with 10 of those shapes. So I'm going to do it down here. For 10 of those shapes. Sorry, I'm just wrestling with a pen here. All right. The first shape took 7. And each next shape takes 5. Remember this other one? Remember the one with the squares? The first shape took 4. And then each subsequent shape took 3. So it's just a question of how many extra shapes were you going to make once you got the first one, right? But each of those ones took 3. In this case, the first shape takes 7, and each of the next shape takes 5 extra sticks. So how many next shapes are we going to have? Well, for 10 of these shapes, and we've done the first one, we're going to have to make another 9. Right? So without even drawing it, without even starting to draw it, right, we know that, using BODMAS, right, that's a sort of a bracket. You do the times first. 9 times 5 is 45, plus 7 is 52. So if you wanted to make one of these guys with 10 of these, 1, 2, 3, 4, 5, right, you would need 52 sticks to do it. Right? Made a prediction without even starting to draw it. Well done. Now you're going to be asked you're going to be asked to do a lot of this in the next day or two. This is exactly how to do it, and now you know what the questions mean. Thanks, guys.